Okay, so here's the big thing. Here's the whole thing that goes through. 2.4. Everything was factored. We worked out. We did synthetic division. We were all good to go. Here's one where we're going to get a problem. Where if you look at it, this thing does not factor. You can go through the options on this thing, and you just don't know what it is based on the problem. Synthetic division doesn't work. Or if you look at it, they don't give you an answer. They don't give you a question. This is one they say, here's a problem. Tell me what the answers are. And you just have to look at it and go, and you don't know at this point. So here's the very first thing they do. They say if you've got a problem and nobody gives you a solution, says try this, try this, try this, here's what you do. Here's what you come up with, so you can at least try and figure out what the answer is going to be. And this is called the rational zero theorem. And what the rational zero theorem does is it gives you all the possible solutions of an expression or of a function. Because everything in chapter 2, we're getting away from equations, we're talking about functions, so we're just saying it's basically the same thing as an equation. But it gives you all the possible, left out one thing here, real solutions. Because there might be an imaginary solution in there, so this one doesn't include that part, but that will come at the very end of if that's a possibility. But it's all, now here's the key thing, it's all possible answers it could be. So this is going to be more answers than you need, but at least you're taking a problem that you have no clue what the answer is, and then this at least gives you a list of what you're going to do. And how you set this up and what you're going to do to get these. That when they talk about the possible zeros, that this is going to be the factors of the constant term. Yeah, and so we don't have to write that every single time. They say, all right, here's a shortcut we're going to do. We're just going to call this P. P is every factor of the constant term that you have, divided by the factors of the leading term. I'm going to run out of room here, so I'm going to put it underneath there. It's the factors of the leading term coefficient, which they're going to call Q. So when they talk about setting this up, it's P over Q. P is the factors of the constant term, and then Q is the factors of the leading term coefficient. So it's 5x to the third, it's all the factors of 5. Okay, so here's the setup when we're going through this one. Here's how this is going to look when you go through this one. And what we'll do next is once we've got the list of term numbers here, we've got all these possible zeros it could be, then we'll actually start doing some synthetic division with these answers that we get. Okay, so the direction should be something like this. List all the possible rational zeros using the rational zero theorem. And we'll do 2 or 3 of these just to make sure we got what's going on. Because there's some that go a little bit fast. Some of them will be really quick, really easy. Some of them it's going to take a little bit longer to get through these. But again, this is just kind of give us the list here. Okay, so any problem you have. Now, most of these, I would think all these problems would be in descending order. They may sneak one in on you occasionally just to keep you on your toes. It's not in descending order. but for the most part, they should be in descending order. So for this part, that's our p-value, which is -4. And our q-value would be the number with x to the third. That q-value would be 1. So we're going to do the factors of -4 over the factors of 1. And if we put a positive there because it's +1, you can do that. Okay, now for this setup, here's all we're going to do. Tell me every different way, and this is not the factor tree. This is more of what numbers can you multiply together to get 4? Do 1 times 4, right? Or you can do 2 times 2. Now, and if you get some number like this one where you get 2 times 2, you don't have to list the name number twice. You just need them there 1 time. Now, here's the catch with this one. We don't know which one's positive and which one's negative. So it could be 1 times -4, or it could be -1 times +4. So we're going to put a plus or minus in front of each of these because it's some combination of positive and negative. Same thing with the 2. We don't know which one's positive or negative, but we'll get that one. And on the bottom, well, there's only one to get 1, right? It's 1 times 1, so we just need 1. Now, same thing with this one. It could be +1 times +1, but it also could be -1 times -1. So we've got to put plus or minus because, again, we don't know how this thing is going to work out. Now, the good news about a problem like this is that when the when the q-value is 1, there's a little bit of a shortcut. Because what happens when you take all these numbers and divide it by 1? Nothing, right? It doesn't. If you multiply or divide by 1, does it change anything? So the answer for this one is going to be just that. It's going to be plus or minus 1, plus or minus 2, plus or minus 4. Okay, so when q equals 1, you have a shortcut because basically it's going to be your p answers. It's all the factors of p because you're going to take everything and divide it by 1, which doesn't do anything, so it's just going to be plus or minus 1, plus or minus 2, plus or minus 4. Now, here's what that means, and this is what we'll actually get to in a minute. When you're starting off with this problem, and you're going to solve this problem, these are the only answers, if we did factor and solving, or if we did quadratic formula or anything like that. Actually, not quadratic formula, because it's x to the third. If we were trying to solve this thing, these are the only answers that possibly could be solutions to this problem. That's it. 1, 2, or 4. Now, you can get into imaginary stuff and the complex numbers, but as far as real answers go, we can actually, put a number on a finger, put it on a number chart and put your finger on it. That's the only possible answers we're going to do. In a minute, we're actually going to go back through and start doing synthetic division to find out which ones of those 6 answers actually work. So right now we're down to 6 answers. One of the old editions, which this book doesn't do it, which I'm glad they don't, had a problem where there were 80 different answers here. And it said, okay, by doing synthetic division, you get these answers. I'm like, okay, they just skipped an hour's worth of work there because they had to do synthetic division on 80 different numbers. I'm like, no, you can't do that. Don't give me 80 numbers and say, oh, here's the answer. No, you've got to show me something. And this edition is better because they don't do that. They actually give you problems where it's a whole lot quicker than that. All right, let's give you another one. Let's bump it up just a little bit here. All right, so f of x, let's go with 3x to the fourth minus 11x to the third minus x squared plus 9x plus 6. So p is 6, or again, if you want to put the plus in there, that's fine. And q is positive 3. Okay, so for this one, q's not 1, so there's not a shortcut for this one. This one we'll have to do a little bit more work to get there. But here's the key thing, is we need the factors of 6 divided by the factors of positive 3. Okay, in 6, there's not that many options. It's either 1 times 6, and again, it's some combination of positive and negative, or it's 2 times 3. Only two ways you can get to 6 with whole numbers. 1, 6, 2, and 3. With 3, there's only one way you can get 3. It's 1 times 3. Now, because there's an extra number on the bottom, here's where we're going to kind of look at it. Because if this answer was just 1, we know the answer would be 1, 2, 3, and 6. So here's where you're going to have more answers to this one. If we divide this thing by 1, it's 1, it's 2, it's 3, or 6. Well, then what they do is they say, all right, after we've got that set of numbers, because we know it's going to be the possibility of that one, you've got to take every one of these answers now and divide them by 3. Because if you think about when this was 3x to the 4th, remember when we did the AC method and we were factoring? How we did 3 times that number to get the factors, and then if we do the bottoms up method, we go back and divide by 3. This one's saying, all right, well, now you've got to have the fact that all these numbers here, you could go back and divide every single one of those numbers by 3. So we're going to do the same thing. We're going to take 1 and divide it by 3, which will give us 1/3. We're going to take 2 and divide it by 3, or 2/3. 3 divided by 3, which is 1, and then 6 divided by 3, which would be 2. Now, for this problem, we've already had 1 and 2 here. You don't have to rewrite those products because they're already back here. So you can basically just kind of scratch these two out because they're repeats. So you don't have to have them. So this would be your answers right here. So if you get repeat answers when you start going back and dividing by the extra number, just get rid of the repeats and you just have to tell me each individual answer is there. So now we've got fractions. Now the good thing is with this one, the fractions tend to work themselves out. You don't have to worry about them too much. They kind of take care of themselves when we start doing synthetic division, and you really don't have to worry about everything that's going on. Okay, so there's how you find, and again, that's all the numbers that could possibly be solutions to that function or that equation. They're actual real number answers that you can put your finger on, rational answers. Sometimes there's some weird answers out there that have got some radicals and some complex numbers, but again, those kind of work themselves out with some other things that we're not going to worry too much about here. Maybe might have one of these at the very end that pops up this way. Mm-hmm. And then, yeah. Now, and here's what we're going to do. Here's what we're going to do with this list of numbers. And we'll get you a problem for this one in a second. From this list of numbers, we're going to do synthetic division with these numbers. And you're looking to find, let's go ahead and say it this way. So to find the actual solutions. And again, sometimes they don't say solutions, sometimes they say roots. Sometimes they'll call them zeros. Answers, whatever you want to call it when we're going through this thing. Solutions, roots, zeros, intercepts, whatever they call those things. To find the actual solutions, do synthetic division. With the possible solutions. And any that results with a remainder of 0. Is a solution. So we're going to do synthetic division. Now this is one of those where people say, all right, well, if we're looking for 0 for a remainder, could we not just do the remainder theorem? Well, yes, you could. And that'll work in most cases, but sometimes when you get to the end, you'll have an answer that maybe, you can find most answers that way. If you do synthetic division and go through the steps on that one and kind of work it down, it'll actually set you up for every answer. There'll be an occasional problem or two that, again, has a square root answer that you're going to have some difficulties finding it just based on how it's set up. So the easiest thing to do to get everything kind of the same so it works out would be to do synthetic division. Here's the one thing that you go kind of one thing to kind of key on as you're going through this one. And this is something they'll mention later, but I'm going to go ahead and mention it now because it's perfect time to put it here. The highest power of x equals the number of solutions. I don't know why they wait. I think it's section 6 when they talk about this. It's the fundamental theorem of algebra. They'll throw that to you in section 6. I don't know why they don't do it now, because it's a perfect time to put it, because you're doing synthetic division on a problem, and some people are like, well, how do I know when to stop? Okay, for any problem you do, if you start with x to the 4th, you got to have 4 answers. If you do x to the 2nd, you got to have 2 answers. If you start with x to the 3rd, you got to have 3 answers. Go ahead and mention it now, because sometimes people don't know. Instead of waiting till the end, tell you now. Okay, that's what we're looking for. So if we were doing this problem here, x to the 4th was our highest power, we need 4 answers. We need 4 solutions from this. Most of them are going to be 1/2, 1/3, 1/6, that kind of thing. You get to the end, you might have an answer that might have a square root, maybe like square root of 7, or it may be that you have to use a quadratic formula at the very end of it. So it may be 1 plus the square root of 7 divided by 2, or something like that. On a very rare case, they might give you an imaginary number. I don't think so, but there's a possibility they could throw out an imaginary number answer at the end. It should either be all whole numbers, it should be either all rational. I think they'll sneak in one problem where you might have to do the quadratic formula to get 1 or 2 answers at the end of it. Okay, so here's where they'll say, list all the possible solutions. And then they'll tell you use synthetic division to find a solution. And then the last thing is then they'll tell you, okay, well, don't just tell me one, tell me all the answers. All right, so here we go. We'll do a couple examples here. Let's give you one that's got a q equals 1 term first to kind of give us something a little bit shorter. X to the 3rd minus 2x squared minus 11x plus 12. So in this case, we'll do an equation. The next one we'll make it a function. Okay, so your P is 12 and your Q is 1. And again, if the Q is 1, we got a bit of a shortcut that all we have to worry about is just the factors of 12. So it's plus or minus 1. You do 1 times 12. You could do 2 times 6. And then you also could do 3 times 4. Now, you don't have to write the terms in order, but a lot of times it's easier if you go back and spread those factors way out, because if you can put them in order, it just seems to make things go better. And again, now we're going to divide everything by 1, but dividing it by 1 doesn't change anything. So let's say this is part A. So that's A. To me, B and C are interchangeable because there's no, it's the same thing. You're still going to keep doing synthetic division. So I don't know why they separate. I don't know why they give you 3 parts on the textbook, but they do. So we'll kind of do the same way. So if you divide by 1, doesn't change anything. So all those possible solutions are part A. All right, here's the B part. There's no rhyme or reason to what goes on with this. You just pick numbers. Now, here's what I would say. If we wind up with fraction answers, and most people don't like fractions, don't worry about the fractions. And don't worry about the big numbers. with the plus or minus 12, start with the small numbers. Start with the ones and then work your way up. I would say probably the easiest thing to do is check positive and negative 1 first. And if that doesn't work, then go to positive and negative 2. If that doesn't check, then go to positive and negative 3. Just keep going up the ladder until you get one that works. And I would say don't skip around, because sometimes people will skip around and they'll miss one, and they'll check these and they'll do stuff, and I'm like, well, but you didn't check negative 1. And they're like, seriously? I'm like, seriously. And I'll go back and check it, and they're like, that worked. So sometimes by skipping around, you can kind of miss the problem that you're looking for. So anybody want to do positive, negative 1? Anybody got a pick? What's that? You're going to do, oh, okay. Positive 1. Okay, let's go for it. Here's where you just roll the dice and see how it turns out. So we're going to do 1x to the third minus 2 minus 11 plus 12. So this is where you just do guess and check. You do not have to change the signs on this one, though, because we're going to check positive 1. We'll also come back and check negative 1. So we're going to hit both of them as we go through this thing. All right, so bring down the first number. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times that's negative 1. Hey, we might have picked the right one here. That's negative 12. 1 times negative 12 is negative 12. All right, we picked a good one. All right, so that's what we wanted. So we got lucky. When that is 0 remainder, that is yes. That's your first solution. So there we go. We've got one solution. All right, now here's what they want you to do from here. Once you've got your first solution, now you could. Some people are like, well, can we keep doing guess and check with synthetic division? Because most of the time people get here and they go, all right, I like synthetic division. It goes quick. You can do that. But here's what they really want you to do. Once you've got your first solution, you've got this one taken care of. Take the answer you've got here, and we'll have to go to the next page because we're out. Because we've got 1 minus 1 minus 12. This was our answer that we had. And if we go back and we started with x to the third, so we go back and put in the powers of x, this is x squared minus 1x minus 12. Here's what they really want you to see. If you get down to x squared, or even x to the third, we'll do in a minute when we get down to x to the third. See if this thing will factor. Now, and you already know what the answers have to be, right? If we go back to the other page back here. Because the answers have to be one of these numbers, right? If everything works out. So they're already kind of telling you, all right, we know this is our list of options that we're going through. So just go back here and let's see what we can do. What are the factors of negative 12 that will get us negative 1? Well, 1 and 12 isn't going to work. 2 and 6 isn't going to work. We can take 3 and 4 and get 1, right? Just make the 3 positive and make the 4 negative. So this would be x minus 3, sorry, x plus 3, and x minus 4. And that makes solving it really easy. This one we'll just subtract 3. And for this one, to solve it, we'll just add 4. And now what was the first one we found? The positive one? Don't forget about that first answer we found back here on the other page. So, and again, the key thing was, if we go back to it, we had x to the third power to start with. You got to have 3 answers. Found the one, and usually, and that's the key thing they try to get you to see, is that once you can get the first answer, once you get past this one, get to the next problem, and instead of doing, now you can keep doing synthetic division, and eventually find all 3 of those answers, and that's okay. But they're telling you, all right, the easier way to kind of get there is once you find synthetic division with one of these numbers, go ahead and start with this problem and see if it factors. If it doesn't, okay, then go ahead and do synthetic division. But when you do synthetic division, do it with this problem because we've knocked it down a power. And then see, once you get past that answer, can you solve it from there by factor? You know, and eventually, at some point in time, you'll keep going through those and getting the answers, and it keeps popping up that way. All right, so let's get you another one. Oh, hang on, I'm going to do that one just yet. So let me find one more here. The one where the first term. Yeah, here we go. I'm going to give you one where the first term wasn't 1 that you had to go back and do some division on, just to make sure you had it there. For this one, it's the factors of 5 divided by the factors of 6. Okay, for 6, got a few more options. It's either 1 times 6 or it's 2 times 3. So this is one of the rare cases where actually when we check it, we're going to have more fractions than we're actually going to have whole numbers on this thing. So we're going to take everything and divide it by 1, which will just be 1 and 5. Then we're going to take everything and divide it by 2, which will be 1/2, and 5 over 2. Take everything and divide it by 3, 1/3 and 5/3. And the last one, divide everything by 6. And again, here's the thing with this one. We've got a lot of fractions. Don't focus on the fractions. Focus on the whole numbers, because the fractions will work themselves out with the whole numbers. You're not going to have an answer that's got everything fractions. So there should be, at least, in most cases, you're going to have more whole numbers than you will have fractions. This one, because we have so many fractions, we may have 2 answers that's fraction, we may have 1 that's whole number. So there should be a whole number in any problem that's going to make this thing work out, and the fractions will kind of, they'll work their way out when we go through this thing. Okay, so which one? Plus or minus 1? Plus 1. All right, let's give plus 1 a try. See what happens. Worked last time, right? We've got 6, 25, negative 24, and plus 5. So 1 times 6 is 6. That's a 31. 1 times 31 is 31. That's a 7. 1 times 7 is 7. That is 12. That is not going to work. Okay, so that one didn't work. Let's try negative 1. And 1 times 6 is negative 6. 5 and 6 is 19. That's positive 19. That's negative 19. This is going to be negative 43. That is not going to get us a 5, so this one's not going to work. Then once you get here and you kind of see it, you know, you go to 43. That's 48. So that didn't work. So now we're down to either positive or negative 5. Okay, I'm going to help us out on this one. It's not positive 5, so let's check negative 5 and see what happens. And sometimes you may have to go through 2, 3. Sometimes it might take 4 or 5 to get there. Now, most of the time it shouldn't be more than that, but usually probably 2 or 3 division problems in, you should start having an answer there. Okay, so we've got 6, 25, negative 24, and a positive 5. So negative 5 times 6 is negative 30. It's negative 5. Negative times negative is a positive. 24. That gets us a... What did I do? Oh, it's 25. Sorry. Look at the number up there and wrote down the wrong thing. There's 25. Sorry about that. That's a positive 1. Negative times positive is a negative 5. That's 0, so that's a yes. That's what we wanted. So the first solution we have is x equals negative 5. So again, we start with x to the third. We're looking for 3 solutions. We've got 1. Now, you could keep doing guess and check with the fractions and see what goes through. But what they try to get you to see is that if you check this thing should factor when you get here. Okay, now the first term being 6x squared, it makes it a little bit more difficult with factoring. So this is where we have to go back and do the whole AC method thing. So we start with 6 times 1, which is 6. So we need the factors of 6, where the sum would equal negative 5. Okay, so it was positive 6 times positive 1, so that's positive 6. And because the sum is negative 5, now there's 2 ways you can get there. Because you could take 1 and 6 and get 5. You could also get 2 and 3 and get 5. So this is where the signs play really important with what you're doing for this. Because this b term is negative, the sign with the bigger number has to be negative. And if you do a positive divided by a negative, that makes this one a negative also. So in this case, they're both negatives. Because a negative times negative would make it a positive. The ones that would add up to negative 5 would be the 2 and the 3. So we've got x. Now, here's where, again, this is where we'll change. Depending on how you learned it, everybody may have done something different on this one. I'm going with the way I kind of teach it when I go through this thing. Once you find these factors, once you find the pair of factors that adds up to your b term, go ahead and write those things out. But because in the beginning we multiplied by 6 to get this number, now you've got to go back and divide by 6. And this will simplify. 2 divided by 6 is 1/3. 3 divided by 6 is 1/2. And now this is one where you don't have to do the bottoms up for this part, because once you've taken, because we multiplied by 6 to get this number, you've got to even it back out. Once you find these factors, we're going to go back and divide it by 6. That way, we multiply by 6, the numbers are too big, we divide it by 6, we're back to even. Once you're here, you just solve that problem. If x minus 1/3 equals 0, just add the 1/3 over. There's your 1/3. Same thing with the 1/2. Just add the 1/2 over. And again, for the third answer, don't forget about the original answer we had there for x equals negative 5. So there's the 1, 2, 3 answers that we need. Yeah. All right, so let me show you this one. We'll get as much in as we can here. We've got a couple other things to get to. We can, one for sure. I don't know about both of them at the time we've got left over. Go ahead and get this one. Okay, once you've done synthetic division, you've done the guessing and checking, you've done all this work to get the answers on this one, the next thing they're going to ask you to do is, okay, we're going to go Jeopardy on you here. We're going to give you the answers. You got to tell us what the question is. So this is one of those things they're going to tell you, all right, find a polynomial equation. Sorry, left that out. So you're finding a polynomial equation when you're given the solutions. So they're going backwards on you for this part. So this is one of those things we're going to kind of work it backwards to get everything that we need here. Now here's one little extra that we need to add before we do this. know what you call this. I don't know if it's a help or it's well, I guess one rule that you have for this thing. I don't think they do anything with radical solutions on this one, but just in case they do, I think everything in this part they stick with the complex numbers. But complex and radical solutions always occur in conjugate pairs. And remember, conjugate pairs just means that if you have one that's a positive, you also need one that's a negative. So if they tell you that 2i is a solution, that also means that negative 2i is another solution. So basically this part, they're going to give you some solutions. They'll give you 1 or 2 or 3, whatever how many it is. But if they give you x equals 2i, then you also have to know that x equals negative 2i is a solution. So that's the part that they won't give to you. They'll tell you, all right, you've got x equals 1, you've got x equals 3, and you've got x equals 2i. They're not going to tell you that x equals negative 2i is a solution. You just have to know that, all right, if they give me an imaginary or complex solution, there's another one that goes with it, because more than likely that answer came out of the quadratic formula. And with the quadratic formula, we always do the plus or minus and the square root. If one of them's positive, you got to have a negative to go with it. So they're always pairing those two things together, because more than likely that answer came out of the quadratic formula to get the answer. And if you get a plus, then you have to minus. Or if you have a minus, you have to have a plus that goes with it. So they're always paired together here. Okay, so here's the question. They're going to tell you that you're given degree of n equals 3. So they're going to tell you right off the bat, here's how many solutions you need. If it's n equals 3, you need 3 solutions. If it's n equals 4, you need 4 solutions. So they're going ahead and telling you what the degree is, which again is also the solutions. And then they'll tell you 1 and 5i are zeros. And then they'll give you one other little thing that's going to help you when you get to the end of it. So this is the one little, if this is basically your 90 to 95% of the work to get this part of it. Here's the one thing at the end that they're going to say, all right, here's one other little detail that you've got to get that's worth, 5 or 10% of what we're doing. And then f of negative 1 is equal to negative 104. Okay. Again, whenever they tell you that n is equal to 3, that means you have to have 3 solutions. Which also means it needs to be x to the third. Okay, so now here's the one thing. They gave us that 1 and 5 hours solutions are zeros. So from these two things, I would just say, all right, we know that x equals 1 is one solution. We know that x equals 5i is another solution. And again, here's the other thing is that if we have positive 5i, we also know that x is going to equal negative 5i. So they gave us the first two. You just have to know that third one is in there. All right, now, here's the thing with this one. Everything is going backwards on this one. So before, this was the answers we had when we were done. We've got to kind of work it backwards. That, if I scroll back up for a minute, when we were getting these solutions, right before we had these solutions, we had it so it was equal to 0. So for this part of it, we're going to have to do the same thing. We're going to have to make it so these are equal to 0. So we're actually going to move this minus 1 back over here. So now we've got x minus 1 equals 0. This was a positive 5i, so we'll move it back over. So it's x minus 5i equals 0. This one we'll add it over, so it's x plus 5i. Okay, and just scrolling back up real quick. When we had those answers here, we had them multiply together. So same thing on this one, but again in reverse order. We're just going to bring these two things, in this case these three things, back together, and we're going to multiply them all together. All right, I'm right up against the page, so let me jump to the next page and bring all this back over. So x minus 1, x minus 5. Okay, now when you do this one, we're going to do the full method to bring it all back together. When you do the full method, do the part with the imaginary numbers first. So let's just say we're going to foil the I terms first. Because that part's going to go away faster and make this thing a whole lot neater. If you go with these two first, where you got one imaginary and one real, it's going to get really ugly in a hurry, and you're going to have stuff all over the place. So when they give you these imaginary numbers, and every problem they'll do on this one, they'll give you an imaginary number. Do this part of it first, because it'll work its way out and be okay. All right, so for this one, we've got x times x for x squared. We've got x for 5i, so that's 5ix. We've got negative 5i times x, so that's a negative 5ix. And then negative 5 times that, so negative 25i squared. So we're going to do this part first. Now, that x minus 1 out front is still there, but again, we're going to hang on to that part. We'll come back to it in a minute. We've got to do this part of it first. Here's the good thing about doing the imaginary numbers part first. The plus and minus cancel each other out. That's going to leave you with x squared. And again, because you have I squared, take out the I squared and replace it with negative 1. So this becomes basically x squared plus 25. Now, if you don't do the imaginary terms first, it's nowhere near. Now, eventually you'll get the right answer, but it's going to be a lot messier before you get there. So when you're doing these problems, do the FOIL with the I terms first, and that way this always comes out to be x squared plus or minus some number. Most times it's going to be x squared plus some number when you go through this one. Okay, and then we're going to do the FOIL method one more time here. Okay, so x times x is x to the third. X times 5 is 25x. Negative 1 is negative 1x squared, or just negative x squared. And then negative 1 times 25 is a negative 25. All right, now, on the test, if we're working this one out on paper and pencil, you leave it here. If that's a 5-point question, you've got 4 of the 5 points. You're good to go. Here's where you get the one last extra point, and here's what you've got to get the full credit in the homework. Here's where they bring in this one last thing at the end. They gave us that f of negative 1 was equal to negative 104. We've got to plug this back in and see what we actually get, because right now, because basically they're saying is that we've done all this work, there might be that each one of these terms might be multiplied by 2, might be multiplied by 3, there may be some constant they were multiplied by, we don't know. So they give us this one to say, all right, plug this back in. That you just got to plug it back in and see what you get. So basically they're saying, all right, check to see if we get negative 104 when you plug in negative 1. If you don't, we got to go back and multiply by something. And that's what we got to figure out here. So it's negative 1, negative 1, negative 1, and everything else we'll go back and put in. So that's to the third plus 25 minus squared minus 25. Now, somebody's probably thinking, does it matter that they're not descending order? No, for this part, we're just plugging in numbers to get a check. ever what the terms are here, we're good to go. Just plug in the number and see what you get. Negative 1 to the third is negative 1. 25 times negative 1 is negative 25. If you did 1 squared, that would be 1. And then we've got the negative in front, so that's a negative 1, and then minus 25. Okay, so that's negative 26, negative 27, that's a negative 52. But we need negative 104. So to get from negative 52 to negative 104, it's half as much. So we need to multiply by 2. So that means we've got to take this answer we had and multiply it by 2 as well. So basically, now, here's what I would do if this were me. If we're doing this out on paper, I would just take this answer you've got here and go back and put a 2 in front, and you're good to go. I don't know if they'll let you do that in the homework. On the homework, they may want you to go back and put a 2 in front of each one of the terms. If you want to try it that way first and see, I mean, you can, and just see what happens. If not, then you may have to go back and actually multiply each one of the terms out by 2 to get that answer. Now, and here's the thing. It should always be a whole number. It shouldn't be anything where you're going to have to multiply by 1.5 or 1.37 or 2.6. It should be 1, 2. Might be a negative 3, negative 4, that kind of thing, but that's kind of what we're looking at.